My name is Luis de los Santos. My student number is 991367373, and I will be discussing the theory part of the ultrasound non-destructive testing. The main purpose of this lab is to find drilled holes without using a visual display and using a non-destructive method, ultrasonic, to locate them. The objective of this lab is to use a method which is non-destructive in analyzing impurities in a material. The lab focuses on using ultrasonic sound waves with a receiver to locate drilled holes in the block and to figure its depth. A UT inspection system consists of a pulsar/receiver, a transducer, and a display screen. The pulsar/receiver can produce a high voltage electrical pulse that will send a wave of energy through the material. Doing so, when there is a breach in the energy's wave path, part of the energy wave will be reflected back to the surface. Then after, the transducer will transform the reflective energy wave into an electrical signal and will be displayed on the screen. What is shown on the screen is the strength of the signal versus the time when the echo of the wave was received. To find location of the defect in the material, we could use D equals V times T divided by 2. V is the velocity of the sound in the tested material, and T is the time taken by the sound wave to reflect back to the surface.
Hi, so my name is Manmeet Saghu, and we are today going to perform ultrasonic testing with this setup. So here we have an ultrasonic testing machine. This is the transducer. This is some oil to put on the test subject. And here is our display, and here is our test subject. This is a thick slab of aluminium. You have holes in it, and we're gonna find the holes, depth, and the length by using this setup. And here is our scale. We're gonna use it. Firstly, we need to set up this test machine. So we turn this on and wait for it to show us the display. It's turning it on. Once we have the phase array, we go into the phase array, and we're gonna take this transducer and gonna put this in. This. Alright. Here it goes. You can screw it in. Once it's done, you have to press this little knob underneath, and here it's on. So we need to check here. By using this, we can change its frequency. And we're gonna use, this is the main transducer, which gonna tell us the depth of the hole or any irregularity in the setup. So here we are gonna perform it. So firstly, we're gonna make this, see the surface is clean on that. Once we satisfy the surface, we're gonna take this oil and put this on the surface. So this oil will reduce the sound waves, and it will not let the sound waves go out and from the surface contact. Here it is, and do it gently, and here. Now clean your hand. To and fro until we we're gonna look for this percentage here. It's 6 to 7%. When this percentage reaches around 50 to 100, then it's supposed to that we have found a hole. So it's now look at this. Look at this. So we found a hole at the depth in. This is the depth and this is the percentage, so it's over 50%, so it's surely a hole here or an irregularity over here. So we just gonna place it, and for the length from the edge we're gonna use the scale to measure the length. So here it is. We're gonna put slightly in the middle. I'm gonna look for the middle, and here it is. It's 2 inches from the side. So this is how we perform this test, and for other holes we have like go to and fro again to find some more if we want. Here it is, look, we found one more here. It's 104 P% B, 104, and it's 2.977 inches deep. Alright, so this is how we perform this test. Thank you very much.
Hi, my name is Gurpreet Singh, and I'm going to tell you about the data and observation that we calculated during the performance of a ultrasonic test in the lab. Here are the data and the diagram of the material that we used. And the material that we used was an aluminum slab. It was rectangular in shape, and here the dimension, it is 9 by 4, and all the units are in inches. And during the performance of the experiment, we were able to collect 4 holes. We were able to find 4 holes in the aluminum slab. All the 4 holes were in different dimensions in the slab. And the first hole was at depth of 1.975 inches from the top and at distance of 2 inches away from the point A. Here is the point A, and energy reflected through this hole was 104%. And the second hole was at a depth of 2.960 inches from the top, and it was at a distance of 4.1 inches from the point A, and the energy reflected through this hole was also 104%. And the third hole, it was at a depth of 1.011 inches from the top and at a distance of 6.6 inches from the point A, and the energy reflected through this hole was also 104%. And the last hole that we collected was at a depth of 3.145 inches from the top and at a distance of 6.7 inches from the point A, and the energy reflected through this hole was 75%. Thank you.
Hi, I am going to explain the discussion of this lab. As you know, this lab concentrates on finding cracks or holes in the aluminum slab with the help of ultrasonic testing unit, which is a non-destructive testing method. We found that during this lab, with the help of ultrasonic testing unit, that there are 4 holes in the slab, but we can use many more methods of non-destructive testing to find the internal or external defects. Some of these are magnetic particle testing, liquid penetrant testing, radiographic testing, ultrasonic testing, electromagnetic testing, visual testing, guided wave testing, laser testing methods, leak testing, magnetic flux leakage, neutron radiographic testing, vibration analysis, and many more. Here I am going to explain the most 3 important tests except the ultrasonic testing unit, which we can use to find the external and internal defects. First of all, magnetic particle testing. What it actually is. It is a very common technique for testing carbon, steel structures, pipes and vessels. This technique is very sensitive for the detection of cracks on surface. It works by applying the magnetic field to the material to be tested. The magnetic field can be applied through York or directly connecting the material to electricity. Electric fields may be longitudinal or circular. These 2 fields can be AC or DC. AC is more sensitive as compared to DC. Next step is to sprinkle particles on the surface of material, which can be dry or wet. Then run the magnetic field and look for any deposition of magnetic flux on the surface. This test will give the exact length of crack on the surface of material. This test can only be performed on magnetic materials. I will show you a schematic diagram of this test on the board here. As you can see, this is the material. It is actually a magnetic material, so we can only perform this test on the magnetic material. This is the crack in the hole, and we have to detect this crack. When we taking this test and connect it to the electricity, the magnetic flux lines flow. They are longitudinal, or in this case. So these are magnetic flux lines. And this is crack. The next step is to spread the particles on the surface. Usually in this crack. So when the electricity starts flowing, it creates a flux on the surface, mainly on the crack, which helps to detect this crack. So this is the major mechanism of magnetic particle testing. We have other techniques also. The next one is liquid penetrant testing. So the liquid penetrance testing is a surface NDT testing. It shows the crack on the surface but not inside the block. So it is only for external defects, as we see that the material testing, the magnetic particle testing is for the external defects too, and the liquid penetrant testing is also for the external defects. This is a simple technique, and surfaces of both magnetic materials can be tested by this test. To perform this test, firstly the surface of material to be tested is screened through roughly. Then the liquid penetrant is sprayed on the surface. This is kind of similar to the ultrasonic testing, as we put the couplant on the surface, coupling material. We use the oil for coupling material in ultrasonic testing. Here we also put liquid penetrant on the surface, and sometimes is given to the penetrant to get set and penetrant into the surface. Then the excess of penetrant is removed, and final step, developer is applied, which reveals crack and penetrant absorbed by the surface. So this is for the liquid penetrant testing. And we also have one more major category known as radiographic testing. Radiographic testing involves a radiation source and a receiving plate to capture image from radiation. The radiation source can be gamma rays or X-rays. This process uses radiation, so it can be very dangerous if somebody get exposed to radiation for too long. So this test also includes dangerous things, so it can't be performed like alone. The test is performed under closed door sections. This test can be used in different industries with variety of purposes, such as testing of cracks and defects in metals, in medical industry, and to measure the authenticity of paintings. So these are the major tests which we can use to find the external or internal defects, except the ultrasonic testing unit.
In conclusion, using non-destructive methods such as ultrasonic, laser, thermal, and many more gives us another way of testing materials without damaging its physical appearance. In the real world, methods like this is used in many different fields. One example would be what oilers do to find pockets of oil in geological areas, and the method that they will be using is thermal and ultrasonic testing. Another example is in the medical field, where hospitals and doctors' offices will have scanners to scan the human body using MRIs, X-rays, and many more.